Hi, I'm David. When an engine misfires, the engine control module will usually set a DTC. Knowing how these DTCs are set will help you when it comes to finding the cause. A P0300 is a non-cylinder specific DTC, and a P0301 to P0312 are cylinder specific. The last two digits correspond to the cylinder number. The combustion process requires the correct amount of air mixed with the correct amount of fuel, compressed to the correct ratio, and ignited at the correct time. A misfire is when one of these elements is missing, not in the correct quantity, or not occurring at the correct time. Too much or too little air can upset the air-fuel ratio. Not enough air could be caused by a partially blocked air filter or a restricted intake tube. An excess of air could result from a vacuum leak after the throttle butterfly. Too much or too little fuel will also upset the air-fuel ratio. Fuel pressure can cause either problem, as can an incorrect fuel injection duration. Leaking injectors can cause an overfueling misfire, whereas a blocked or partially blocked injector can cause a lean misfire. Poor compression will not only result in a lack of power, but can also cause a misfire. Low compression can be caused by burnt, worn or improperly adjusted valves, worn piston rings, or a faulty head gasket. If the fuel and air mixture is correct and there is sufficient compression, then the ignition system could be the cause of the misfire. A non-existent or poor spark, worn, corroded or incorrect spark plugs, or incorrect ignition timing could result in a misfire. So how does an engine control module detect a misfire? Each time a combustion process occurs, the crankshaft will accelerate due to the expanding gases. The engine control module is able to detect the variations in crankshaft rotational speed. By monitoring these variations for each cylinder, the ECM can detect individual cylinder misfire events. These DTCs are a type B, meaning if the control module detects an emission level misfire condition during 2 consecutive trips, the control module illuminates the engine check light. If the control module detects a high level or catalyst damaging misfire, the module will flash the engine check light. A catalyst can be damaged by unburnt fuel entering the system. If the control module detects a misfire during 2 non-consecutive trips, any stored conditions are compared with the current conditions. If the engine load is within 20%, the engine speed is within 375 RPM, and the engine coolant temperature is in the same range, the engine control module will turn on the engine check light. It is possible for the engine check light to turn off again before the customer has the vehicle looked at. This will occur if there are 4 to 8 consecutive ignition cycles without the fault reoccurring. The engine check light will be extinguished, but the DTC will remain in memory. If the engine goes through 40 warm-up cycles without the fault occurring, the DTC will be removed from the ECM's memory. This can make diagnosis difficult. A misfire DTC can be present without an actual misfire occurring. Driving on a rough road is often enough to cause a crankshaft speed variation. Many vehicle manufacturers use the wheel speed information or a rough road sensor to prevent the misfire DTC from occurring under these conditions. Defective drive belts or abnormal engine noises are other possible causes of these DTCs. A loose or incorrectly installed engine automatic transmission flex plate, engine flywheel, or crankshaft balancer may also set these codes. That's our look at P0300 to P0312. Knowing how these DTCs set makes diagnosing them a lot easier. There are many tests that are required to find the cause of a misfire. These will be covered in our diagnostic modules for these codes. And always remember, training is the key to your success. Bye for now.